Okay, so what I'm going to do next is I'm going to go ahead and work on these FRQ problems. So for the first part, they're asking us to find f prime of 5.5, right? To approximate it using data from the table. So here's 5.5, 3.244. Now, normally we're used to doing, to approximate, we're used to doing f of b minus f of a over b minus a, right? So we might think, okay, maybe I'll do f of 6 minus f of 5 over 6 minus 5, right? However, this is not going to work for us in this problem because if we look up here, f of 5.5 is right here, right? And so 5 would be a part of the graph, but notice that when we get to 6, we jump down to right here. Yeah, so if we were to use the value from the table for 6, we would be actually using this bottom piece of this piecewise graph, meaning that our average rate of change would not be as accurate as we would want this to be. So we need to choose a better point, and what we would use is actually this right here. Okay, so f of 5.5 minus f of 5 all over 5.5 minus 5. And so that becomes 3,244 minus 3,455 all over 0.5. And that leads us eventually to an answer of negative 0.422. So that would be the first part of this. Now the second part is our value x from 0 to 6. So from 0 to 6, so keep in mind we're only looking here, right, such that the limit, so this is basically asking us for the f prime of x equals 0. Right, is there a point? And give a reason for your answer. And so what I would say is that at x equals 4, right? So at x equals 4, there is a horizontal tangent line with a slope of 0, right? With an instantaneous slope of 0, and then kind of explain that this is the formula for f prime, the limit definition of a derivative, and that's it. Okay. And then for part C, so now we're looking at 6 plus h, 6 plus h, 6 plus h. So we are looking at this half of the graph, right? And we are interested in f prime of 6, basically. But we already know here at 6 that it's going to be d and e because it's not continuous. Right, so keep that in mind as we're solving this. Now, for each of the expressions, find the limit. So as limit approaches 0 from the right, so here I am approaching 0 from the right, I would use, let's see here. So my best approximation would be to use that. And so I would use f of 6.5 minus f of 6 all over 0.75 minus 1, which leads me to an answer of, it looks like negative 1/2. Okay. Oops, I'm sorry. I totally made a typo here. So, so 0.75 minus 1 all over 0.5. So negative 0.25 over 0.5, which is equal to negative 1/2. Okay, and my e-pencil is not working too well right now. There it is. Now from the left, it's d and e, because right here from the left, this would not work for us. And then because of that, it's d and e. Okay. All right, number 10. Or not number 10. Number 17. Okay, so this problem is not too well. So the issue here is that this guy, we haven't learned how to find the derivative of him yet. However, we do know that it's a first times the derivative of the second plus the second times the derivative of the first. And one thing that I mentioned in class was that you can type this function in to your calculator by clicking on math, clicking on nderiv, and then you can type in ddx of x squared e to the cosine 3x, and then you can interpret that at x equals, and then whatever the value is here that we're trying to find. So whether that be 3, whether that be 5, whether that be 7, the calculator will help us to find that. So the first part, using the values, estimate f prime of 4. So another average rate of change. Now 4 falls in between 3 and 5. So we're going to say f of 5 minus, well, okay, you know what? We need to say average rate of change is f of b minus f of a over b minus a. And so we can say to approximate f prime of 4, that would approximately equal to f of 5 minus f of 3 or 5 minus 3. And then you just show all the work that leads to that answer. So f of 5 would be 4 minus negative 1 over 5 minus 3, 5 over 2. And so there's our answer. Now for this one, so f prime of 3, so that would be equal to f prime of x plus h prime of x. So m prime of 3 would be equal to f prime of 3 plus h prime of 3. So for f prime of 3, we run over to our table, and we see that that's 8. And then for h prime of 3, like I mentioned here, you would take your calculator, type in this and derive, and whatever number you get, you put there, and then you add that up. And then you would end up getting an answer of 5939 or 5938. Okay, so that's what we're looking for. So that's what it is for all of these parts. So this is just first. So n prime of x would be the first times the derivative of the second. So the first times the derivative of the second plus the second times the derivative of the first. So that's equal to f of 5 times h prime of 5 plus h of 5 times f prime of 5. And so when I jump over to 5, I get 4, and then I get 3. And then h prime of 5 is the one that I need to type into my calculator. And then the h of 5 is just 5 squared times e to the cosine of 15. And make sure you're in radian mode when you type that out, okay? And so there would be, and then that would eventually lead you to an answer of, let's see here. I don't see an answer. Oh, there it is, negative 37.465. Okay, and then part C is our quotient rule. So second times derivative of the first minus first times derivative of the second, all over second squared. And so f of 7 times h prime of 7 minus h of 7 times f prime of 7, all over f of 7 quantity square. Right? And then you just go to your chart, do the same thing, you work that out, and then you have to get an answer of negative 8.3, negative 8.93, or negative 8.929, that kind of idea. Okay, so there